Is the end of Betelgeuse near? There's no doubt that the massive star will eventually depart the cosmic stage in a violent explosion, but according to some scientists, this dramatic event might occur sooner than expected. So what does this mean for us? Will the colossal supernova throw our planet into chaos? And why is Orion's shoulder star behaving in ways that have left astronomers puzzled? Larger than the Sun in our everyday understanding, our mother star often serves as the benchmark for all cosmic objects, unmatched by any other celestial body. In relation to our solar system, this holds true. With a diameter of at least 1.4 million kilometers, the Sun easily surpasses all its planetary neighbors. In theory, Earth could fit into the Sun more than 1.3 million times. However, our central star starts to seem much smaller when compared with other galactic giants. Positioned in the constellation Orion, Betelgeuse vastly outshines our fixed star in almost every astronomical sense. Specifically, the giant star, known internationally as Betelgeuse, boasts a diameter 800 times that of the Sun. In this comparison, the Sun shrinks to a tiny dot, which would fit 500,000 times inside Orion's shoulder star. The difference in brightness is just as extreme. Betelgeuse shines 10,000 times brighter than our source of heat and light. As a result, it's visible with the naked eye from Earth, even though it's about 650 light-years away. If you're in the northern hemisphere during winter, it's almost impossible to miss the red supergiant. This isn't a new phenomenon either. Betelgeuse was mentioned over 2,000 years ago as a yellow-orange glow in the night sky. But like all celestial objects, Betelgeuse isn't a static, unchanging star. Quite the opposite. Measurements of its radius using interferometry have revealed that it fluctuates by about 15%. Interestingly, Betelgeuse's radius was the first to be determined using this technique. These fluctuations aren't limited to its size, they also affect its brightness. Every 270 days, there's a visible change in luminosity due to the late stage of development that Betelgeuse is in. Red supergiants like Betelgeuse tend to expand and contract, and this pulsation directly ties to brightness changes. However, a few years ago, astronomers were struck by just how drastic and baffling this behavior could be. An unexpected phenomenon occurred in October 2019, when a process began that resulted in a sharp decline in brightness. By February 2020, its luminosity had dropped to less than 40% of its usual value. This was unprecedented in the history of astronomical studies of Betelgeuse. Once astronomers noticed this mysterious dimming, they quickly sought to understand its cause. Some believed the drop was due to overlapping brightness cycles. Others feared something far more dramatic, the onset of an imminent supernova. Typically, such stellar explosions are preceded by significant expansion and a sharp decrease in brightness. However, since no star has ever been observed directly before a supernova, it's unclear whether this dimming happens years or only hours before the event. Nonetheless, it's certain that Betelgeuse will eventually go out in a massive explosion. According to current estimates, Betelgeuse won't leave the cosmic stage for at least 1.5 million years, as it only recently entered its final phase of life. However, some researchers suggest the supernova could happen within the next 100,000 years. After Betelgeuse returned to its former brightness in April 2020, scientists uncovered the cause of the drastic dimming. In August of that year, data from the Hubble Space Telescope revealed that the star had ejected a massive cloud of hot, dense material. This material cooled, condensed into dust, and blocked some of the star's light from reaching Earth. The cosmic dust veil made it appear as though Betelgeuse had dramatically dimmed. With this mystery solved, the star didn't take long to present another enigma. Since 2023, Betelgeuse has been shining much brighter than usual. What will happen when Betelgeuse finally explodes? Whether it happens soon or thousands of years from now, one thing is certain: when the red supergiant goes supernova, it will remind us of the tremendous forces at play in the universe. As mentioned, Betelgeuse already shines 10,000 times brighter than the Sun, but researchers predict that its luminosity will increase 16,000-fold during its explosive death. Some believe the star's brightness will rival the crescent moon, while others think it could be as bright as the full moon. Either way, the supernova will be impossible to miss from Earth. But how will this dramatic event affect our planet? Could Earth be destroyed? Fortunately, the situation is not that dire. The main concern with supernovas is the gamma-ray burst that accompanies them. In Betelgeuse's case, however, astronomers believe we are safe. The star's axis of rotation doesn't point towards Earth, meaning the gamma-ray burst won't be strong enough to harm us. What's more exciting is the possibility of two flashes after the star's core explodes. The ejected material could collide with the static shell around the red supergiant, triggering another explosion visible from Earth. Once the fiery show is over, what will remain of Betelgeuse? Will its former spot in the sky be an empty void? Likely not. As is typical for stars of this size, Betelgeuse's supernova will probably result in the formation of a neutron star, a remnant with a mass 20 times that of the Sun. Is Betelgeuse spinning too fast? Neutron stars are known for their incredible rotational speed. In 2004, astronomers found one that spins 716 times per second. Although Betelgeuse isn't yet a neutron star, its rotation has already baffled scientists. Images from the ALMA Observatory in Chile suggest Betelgeuse is spinning unusually fast. The star's rotational speed, over 5 kilometers per second, is about 50 times faster than expected for a red supergiant. Typically, stars slow their rotation as they expand, and Betelgeuse is the only known supergiant with such a high rotation speed. What could explain this? One theory suggests that Betelgeuse swallowed a smaller star at some point in its evolution. This stellar merger could have transferred angular momentum, speeding up Betelgeuse's rotation. However, according to Jing-Zi Ma from the Max Planck Institute for Astrophysics, the explanation could be different. Betelgeuse's surface is filled with massive bubbles of rising and falling plasma, called convection currents. These currents may be affecting the rotational measurements. The star's surface shows a blue shift on one side and a red shift on the other, which scientists usually interpret as rotational movement. But convection currents can also cause these shifts, creating a bipolar velocity field that mimics rotation. In this case, Betelgeuse might not be spinning as quickly as it seems. Future research, particularly with higher resolution images from ALMA, will help unravel this mystery. Some observations have already been made, but the data is still under analysis. And we'd love for you to keep following these developments by continuing to watch our videos. Don't forget to like and subscribe so you never miss another exciting update from us.